So, hi everyone, welcome to the class. Hi Notion. So, I explained the video, a complete motionless straight line, first year chapter. Okay, just check once, you can check the video. Tanu Shorts. Hi sir, how are you? So, I am fine, doing great. So, welcome to the class, everybody. So, welcome to the class. I am Shiva sir. Myself is Shiva sir. So, I am from Student brand. I am your student. Hey Tanush, where you are studying now? Where you are? C1B, right? Hi sir. Yes, yes. My nose are recorded. Okay. So, very good notion. Ah, Tanu shorts. Techno. Okay. Okay then. Tanush from Techno. Eh? Right now you are 10th standard. Right now you are 10th standard or already completed? Tanush? No, no. Right now you are 10th standard. Okay. Got it, got it. Yeah, got it, got it. Sir, can you explain questions from units and measurement chapter? Yeah, definitely, Notion. You are not attending the class. I am checking every day whether you are attended or not. You only asked because of you only I kept the timing and started teaching. So you after that you are not joining. Maybe timings problem I can understand. Uh, Tanesh, okay. Hi Sivani, welcome to the class. Welcome everybody. Welcome to the class. So everyone join to the class. It's cause get home at 6. Okay. Okay, it's fine. Sir, who could have removed the. Yes, but will do. It's it's a part of the teaching, no? That's why without that I can't able to move forward. That is a problem. Definitely, I will do some other way. Okay, I'll some other way I'll find out to go with teaching. Definitely, I'll check. Okay, now it is clear. Okay, done. Okay, so it is clear now. Uh, So what is the question? What is the question? What is the question? If you would say me, I will do it. Okay. So otherwise, we'll start. We'll start now. U equal to and V equal to 0. S equal to what about A equal to B minus U by SC. S equal to UT plus half AT square. V square minus U square equal to 2S. V square minus U square equal to 2AS. Find out acceleration. V square minus C square equal to 2AS. So here V is there, U also there, and 2AS. So S also there. U, V there, S also there. Find out A value. A equal to V minus U by T. T we can find out. Simple, right? No. So V square. So substitute anyway. V0, 30 square. Try it once, no problem. Sir, don't study up to this topic. There will be a problem for me to understand. Shivani, V square minus V square equal to A, find A. Okay. I said no. So in this A you can find out A equal to V minus U by T. T we can find out. Check once. If you are not getting, we'll do it. Okay. So anyway, values are there. No values if you are there. So here 0 minus 30 square equal to 2 into A value A equal to into 10. 30 square is 900 and 900 by 20. SR 0 get cancel 45. 45 will get minus 45. So here initial velocity is that minus 40 will get minus 45. Then you can substitute. Tanesh, you can do it. Okay, try once. You'll get 45 minus 45 here. Anyway 0 minus get cancel. Okay, so T equal to U value 30 by 45. So I hope you'll get a 0 something because 30 by 45 it is. 30 by 45. Sir, the answer is something else. The answer is all 33 times. I'm getting. What answer you got? What answer you got? No, what is the answer you got? Can you tell me? No, you're a 10th, right? You are solving 11th grade topics. What happened? So, how it is possible, Savani? 10th is not yet finished, right? Okay, done. So fine. So today, light reflection, diffraction, elaborately I am explaining. So still, yes sir, but this question was easy to, so I tried solving. No, actually, bro, first change. 30 kilometer per hour they given or meter per second? My here they given 30, actually K is there, 1000 they given. Okay, we have to convert it to meter per second. 5 by 18 you multiply. 5 by 18. Okay. I thought 30. So actually 30K given. Okay, try to see 5 by 18 you have to multiply. 5 by 18. 5 by 18. Okay, so if you do it, then you'll get it. So kilometer per hour into meter per second. Kilometer per hour into meter per second. Actually, the conversion is very important. Conversion is so normally 1 kilometer per hour. So if you are taking 1000 by 3600, so they'll be at 5 by 18. So 2 5 is to 18. So if you are converting kilometer per hour, so you have to multiply with 5 by 18. Then you'll get main meter per second. Sir, yes, U is 25 by 3 meter per second. Okay. Then you can substitute. Okay, fine, try. So if you're not getting, I will explain. Okay, in Dell I will explain. Okay, it will take time. So because today I planned a long session. Today I planned long session. So light reflection and diffraction, easy only, might is easy only. So nothing else. If you follow the process, it will be. Because I will come at 10 a.m. I have. Okay, done. You can carry on. That only, right? Same process. Yes, you can follow the same process. Okay, fine. So come to the point. So we'll go to the light reflection and diffraction. Light reflection and diffraction. So very important topic for a long time. So it is lengthy session. Lengthy session. I planned everything. Light reflection and diffraction. Light reflection. Light reflection and refraction. Refraction. Okay. So question and answers will be there. Question and answers will be there. CBSE grade 10 physics. CBSE grade 10 physics. So CBSE grade 10 physics I am taking. Okay. So now CBSE grade 10 physics. Okay. So okay. Thank you so much. So now we are going to the next one. So light is a form of energy. If you are taking the plane mirror, light is a form of energy which gives the sensation of sight. When the light is incidenting on it, so it will be reflected back. That is that I'm considering the incident ray. This is the incident ray, and this one is considered as a reflected ray. So incident ray, reflected ray. The line which is perpendicular to the surface. Okay, KS Gaming, what is your name? Can you tell your name? Okay, nice. So you got 2.46. Okay, done. Nice. So if you are taking the normal line, so I'm taking the normal line. So incident ray, reflected ray, normal line. So the angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. So I'm considering this one is undeviated line. The angle between reflected ray and deviated line is called angle of deviation. Okay. So angle of deviation I'm considering. Angle of deviation. So angle of deviation, angle between incident ray and normal line is called angle of incident, angle between reflected and normal line is called angle of reflection, angle between undeviated line and reflected is called angle of deviation. So now if you are considering the okay, loss of reflection. So coming to the loss of reflection, how are you, sir? How are you? So I am fine, Amar, and everybody. Kushal Singh. Okay, very good, Kushal Singh. What are you wearing, sir? So this is the costume. I already told you. Oh, Okay. So great, nice, keep it up, well done. So I'm considering here loss of reflection. Loss of reflection is are nothing but, so first one, incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Angle of incident equal to angle of reflection. Angle of incident equal to angle of reflection. Angle of incident equal to angle of reflection. Incident ray, reflected ray, normal line lies on the same plane. Angle of incident equal to angle of reflection. So according to that, so we are considering this angle. So angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. 180 degrees from angle of, from this point, so from this point, so angle of incident equal to angle of reflection. So I am taking, so angle of incidence plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of incidence. So in the place of angle of incident, we can substitute angle of reflection. So by that we can take angle of reflection plus angle of reflection plus angle of 180 degrees equal, angle of deviation equal to, so I'm taking the angle of deviation here. Angle of deviation equal to 180 degrees. So angle of deviation equal to, so 180 minus 2 angle of reflection. So you can see angle of deviation equal to 180 minus 2 angle of incident. Angle of deviation equal to 180 minus 2 angle of reflection. So we can take like this. Understood? So we have from loss of reflection, angle of incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Angle of incident equal to angle of reflection. Angle of incident equal to angle of reflection. Angle of incident equal to angle of reflection. So angle of incident plus angle of reflection plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of incidence. So like that, angle of deviation equal to, we can take 180 minus 2 angle of reflection. 180 minus 2 angle of reflection. So by this we can take, by this we can consider. So this is about angle of deviation. Next we are going to the next topic is regular reflection and irregular reflection. Regular reflection and irregular reflection. So questions will ask, they based on the angle of deviation and angle of reflection. And one more thing, so based on the incident angle, reflected angle. So based on the angle of incident, angle of reflection, I will tell one question how they will ask related to angle of incident and angle of reflection. So if the light is passing along the normal line, so angle of, so if you are taking this one, if the light ray is passing along the normal line, okay, so what is angle of incidence, first point, and coming to the angle of reflection, and third point is angle of deviation. So what is angle of incident, angle of reflection, angle of deviation? So when the light ray is passing along the normal line, if the light ray is passing along the normal line, angle of incident is 0, because so when light is incidenting along the normal line, so light ray is incidenting, so actually I'll teach only physics, sorry for that. So I have only, I can teach only physics. That is the reason. So if you need any classes regarding physics, you can contact this number 9849812804. So regarding physics, so try to understand. Okay, so that is the reason, nothing else. So okay, come to the point. Angle of incident is 0, angle of reflection is 0, angle of deviation. So the angle between reflected ray and deviation and undeviated line is called angle of deviation. So this angle is called 180 degrees. This angle is called 180 degrees. So angle of incident is 0, angle of reflection is 0, angle of deviation is 180 degrees. So this type of questions they will ask. Even in the so one more also we are talking. So when the light ray passing along the normal line to the concave mirror also, that also it will take place angle of incident, angle of and angle of deviation. So next one, regular reflection and irregular reflection. So regular reflection reflection, and coming to the irregular reflection. Regular reflection means I am taking this surface, plane surface. So this is the incident ray. Incident ray I am taking. These are the incident rays. These are the incident rays. Reflector light rays parallel to each other. Reflector light rays also parallel to each other. So incident beam is parallel. Reflector beam also parallel. Incident beam is parallel. So incident beam is parallel, reflected beam is also parallel to each other. That type of reflection is called regular reflection. So maximum textbook we have to follow, ma. Textbook I'll refer. So CBSE grade 10 physics. Science textbook thoroughly you prepare. Science textbook thoroughly you prepare. So local books whatever you are following, that is okay, fine. Okay. So that's enough. And the remaining books are there. So many books. NCRT compulsory, NCRT, so thoroughly you have to prepare NCRT. That is only best method, best process. Okay, remaining you can, that is your wish later. Other than that, your reference. Irregular reflection I am taking. So regular reflection takes place on smooth surface. So incident beam is parallel, reflected beam also parallel. This type of reflection is called regular reflection. Irregular reflection is nothing but, so my biodata I kept here. Okay, so you can check here. So regular reflection means incident beam is parallel, but reflected beam is not parallel to each other. So reflected beam is not parallel to each other. They will move in different direction. So I am considering here. So here you can take. So this is about incident beam. These are the incident beam. So reflector light rays are not parallel to each other. They will move in different directions. So they'll move in different direction. Okay. So they'll move in different direction. So that is about irregular reflection. Irregular reflection takes place on rough surface. Irregular reflection takes place on rough surface. Regular reflection you see. So regular reflection you can see. So here incident beam is parallel, but here reflected beam also parallel. Incident beam is parallel, reflected beam also parallel. So this type of reflection is called regular reflection. Irregular reflection means, so incident beam is parallel, but reflector light rays are not parallel to each other. So reflector light rays are not parallel to each other. So this type of reflection is called irregular reflection. So this type of reflection is called irregular reflection. I hope it is very clear. Next one, we are going to the next one. Okay. So regular reflection takes place on still water and plane mirror. Irregular reflection takes place on rough surface, book, and wall also. See, one more questions they will ask related to. So now I will be adding question and answers also to this one. Till now I explained about only concept. Now we are going to explain. Now we are going to add a question and answers also. Okay. So regular reflection. So here a plane mirror reflect the light rays. The wall also reflect the light rays. Plane mirror reflect the light rays. At the same time, wall also reflect the light ray. What is the difference between this reflection? So here you can observe this type of questions they will ask. So this type of reflection is called. So here plane mirror you can see. Plane mirror I am taking. Plane mirror regular reflection takes place. On a wall irregular reflection takes place. So that is the difference. There, so incident beam is parallel, reflected beam also parallel. On the wall, incident beam only parallel, reflected light rays are not parallel to each other. So that is irregular reflection or also diffused reflection. So that is the reason. So questions they will ask related to regular reflection and irregular reflection. Coming to the object and image. I am taking here. Okay, so I am considering here. Okay, so I am considering here like this. So this is the object I'm taking. So light rays are coming from it. Light rays are coming from it. Okay, so reflector light rays. These are the reflector light rays I'm taking. Reflector light rays. Okay, so we are extending this light rays. We are extending this light rays. We are extending the light rays here. Okay, so here I'm considering. Here I'm considering this is a real object and this is a virtual image. Virtual image. And one more case I'm taking. One more case I'm taking here. One more case I'm taking here. So here is the pole, sorry, so like we can say, so I'm considering here, so light rays are coming from infinity, light rays are coming from infinity like that. So after reflection, though light rays will meet at one point, though light rays will meet at one point. So here we can see, if you are extending this light rays, 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 so yeah, image will form here. So those light rays will meet. So we are extending the incident rays. We are extending this incident rays. These incident rays are meeting at one point. These incident rays are meeting at one point. That is a virtual object. Virtual object. Here is the real image. Real image. So what is the difference between real object, real image and virtual image? Question is, what is the difference between so here, what is the difference between virtual image and real image? So question. So very important question. What is the difference between real image and virtual image? So real image means real image. Question MCQ's point of view, very important. MCQ's point of view. So I'm telling MCQ's point of view. This question is very important. That is, so what is the difference between real image and virtual image? Real image and virtual image. What is the difference between real image and virtual image? So what is the difference between real image and virtual image? So real image, if you take the direct meeting of reflector light rays. So reflector light rays are meeting directly. Reflector light rays are meeting directly. Reflector light rays are meeting directly. So that is a real image. The reflector light rays are meeting directly. That is a real image. Here, so extended reflector light rays. Extended reflector light rays. So the difference between real image and virtual image. The difference between real image and virtual image is so real image will form the point of intersection of reflector light rays. Real image forms when reflector light rays directly meeting. So virtual image will form the extension of reflector light rays. So that is a difference. That is a difference between real image and virtual image. Real image and virtual image. Okay, so I hope it is very clear. Next one, coming to the real object and virtual object. So directly incident light rays are coming. So here light rays are coming from that point, from one source, that is a real object. So we are extending the incident light rays. After extending the incident light rays, those light rays are meeting at one point. Their object is there. That is a virtual object. Okay, so here is one question. They will ask about what is the difference between real image and virtual image? What are the differences between real image and virtual image? So that questions they will ask in the exam. So either 3 marks question also they will ask, 3 marks question, and 2 marks question, 1 mark question also they will ask. So what are the difference between real image and virtual image? Real image, so the point of intersection of reflector light rays. Directly the reflector light rays meet, then image will form. That is a real image. Virtual image means extending reflector light rays. Extending the reflector light rays. That is a virtual image. So real image can be caught on the screen. So real image can form on the screen. Virtual image cannot be formed on the screen. Okay. So real image can be caught on the screen. Virtual image cannot be formed on the screen. So that questions they will ask. So still elaborately when question comes, we'll go through that. So what is the reflection? So now we are considering. Now if you are taking, so by this observation we can conclude that, so object and image. Object is real, image is virtual. Object is real, image is virtual. Object is virtual, image is real. So object is real, image is virtual. Now you are considering object is real, image is virtual. Object is virtual, image is real. Once again, so if it is there, object. So Tamnesh, so hi, and so I hope it is very clear to you all. Very clear to you all. Object is real, image is virtual. Object is virtual, image is real. So in this concept, hi, okay. So in this concept, so they will ask two questions. Question number one. So what is a real image and virtual image? What is a real image and virtual image? So second question, difference between real image and virtual image. Difference between real image and virtual image. Difference between real image and virtual image. Point number one. So what is real image and virtual image? Point number two. So difference between real image and virtual image. Difference between real image and virtual image. So these questions they will ask in exam. So still once question and answers come, still we will discuss about it. Now we are going to the plane mirror. Characteristics of the image formed by the plane mirror. Plane mirror. So we'll discuss about it. So after that, question and answers we'll discuss. So I already said this is a long session because I planned many points. I'm considering here. So if you are taking the plane mirror, okay. So plane mirror I'm considering like this. So I'm considering here object. So I'm taking AB. So how many letters are required to form the image of the object? How many minimum? How many letters are required to form the image of the object? Minimum 2 letters are required to form the image of the object. Minimum 2 letters are required to form the image of the object. So as I said, if the letter is passing along the normal line, so it will reflect back into the same medium. So the same here also, one letter I am taking like this, so it will reflect back. Another letter I am taking like this, so it will reflect back. So I am considering here. So one more letter I am taking like this, and another letter I am taking like this. So here I am considering. Like this. Okay. So here if you are taking, like this. So I am considering here. Okay. So if you are taking like this, and if you are considering like this. Okay, so here image will form. Extending of reflector light rays. gives the image. Here it is forming A dash, and here it is B dash. So what type of image will form? Virtual image. So only plane mirror case. So if they ask the question in the exam, they will ask, so what type of image will form in the plane mirror? So in the plane mirror, virtual erect and same size. Okay. So the magnification of the plane mirror is positive. Magnification of the plane mirror, if you are taking, okay. So magnification of the plane mirror is positive, that is plus. Magnification of the plane mirror is positive, that is +1. So if you are taking m equal to +1, so only in the plane mirror only we will get magnification is +1. Okay. So first point is, as before I said, object is real, image is virtual. So image if you are taking, object is real, image is virtual. Object is real, image is virtual. Image is real. Second point is object, the distance between object to mirror, object distance. So the distance between image to mirror. So image to mirror is called image distance. Object distance is equal to image distance, and also height of the image equal to height of the object. Height of the image is equal to height of the object. So object is real, image is virtual. Object is virtual, image is real. Object distance is equal to image distance. Height of the object equal to height of the image. Height of the object is equal to height of the image. Okay, so this is about height of the object is equal to height of the image. I hope it is very clear to you all. Okay, so now next one, we are going to the next one. Okay, so this is about plane mirror. Right? So I will ask few questions related to plane mirror. So I already said few questions related to plane mirror will discuss. Related to plane mirror will discuss. So very important questions. Very important questions. Okay. So define reflection of light. Define reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. State the laws of reflection. Angle of incident equal to angle of reflection. So incident ray, reflected ray, normal line lies on the same plane. So define regular reflection and irregular reflection. Regular reflection means when the incident beam is parallel, so reflector light rays also parallel. That type of reflection is called regular reflection. So define irregular reflection. So incident beam is parallel, but reflector light rays are not parallel. That is called irregular reflection. List the characters of the image formed by the plane mirror. List the characters of the image formed by the plane mirror. So here object is distance is equal to image distance, height of the object equal to height of the image, and also image shows lateral inversion. What is the lateral inversion? The phenomena of converting of right side of the object appears to be left side of the object appears to be right side. If you are taking right side of the object appears to be left side of the image, left side of the object appears to be right side of the image. So this is called lateral inversion. So name the phenomena responsible for the following effect. When we sit in front of a plane mirror and we write with our right hand, when you sit in front of the plane mirror, if you write with if you write with your right hand, it appears in the mirror that we are writing with the left hand. So you are sitting in the plane mirror. In front of the plane mirror. You are sitting in front of the plane mirror. So you are writing with your right hand. So in the mirror it appearing with you are writing with the left hand. So what is the phenomena? So this is a custom. So teaching it, one of my teaching it. So my own designs. Okay. So like this. So that is nothing but lateral inversion. So what is the type? What type of image is formed in the plane mirror? What type of image will form in the plane mirror? Virtual image. On cinema screen, real image. On cinema screen, it is real image. See, what type of image will form in the plane mirror? Plane mirror is virtual image. On cinema screen is real image. Okay, see, already said these questions they will ask in the exam. Differentiate real image from virtual image by giving 3 points of difference. As I said, if the light ray after reflection directly it will meet, that is called real image. Extending of reflector light ray, that is virtual image. Real image can be obtained on the screen. Virtual image cannot be obtained on the screen. A real image always inverted. Virtual image always erect. A real image formed by only concave mirror and convex lens. A real image will formed by only concave mirror and convex lens. Virtual image can be formed by concave mirror, convex mirror, plane mirror, and concave lens also, and convex lens also. Last case, concave convex mirror and plane mirror and convex lens, virtual image at the last case, and concave lens also. I hope it is very clear. So very important 3 marks question, difference between real image and virtual image. Coming to the next one, what is the radius of curvature? So very important I am considering. So few questions we are discussing. Few questions I am discussing now. Here you can see what is the radius of curvature of the plane mirror. Radius of the curvature means the center to the pole. Where is the center for plane mirror? No. So if it is circle, then we can get, but there is no circle, right? It's a plane mirror. So that's why it is a radius of curvature is infinity for plane mirror. So infinity. And what is the power of the plane mirror? So they are asking about power of the plane mirror. So power of the plane mirror. So what is the power of the plane mirror? So can you tell me? Power of the plane mirror. So P equal to 1 by F. Already R equal to infinity. So R equal to 2F. Right? R equal to 2F. So automatically F also infinity. So now P P equal to 1 by infinity. P equal to 1 by infinity. But here one thing you have to understand. Here one thing you have to understand. Here one thing you have to understand. So infinity is nothing but 1 by 0. Infinity is nothing but 1 by 0. Yes or no? Infinity is nothing but 1 by 0. So P equal to 1 by 0. Then if it is reverse 1 by 1 into 0, then power equal to 0. Power of the plane mirror is 0. Answer is power of the plane mirror is 0. Very, 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 very important. Power MCQ's point of view, very important. Power of the plane mirror is 0. Power of the plane mirror is 0. Just check it once. Very, very important. Very, very important. Already we are discussing this question. So power of the plane mirror is 0. So radius of plane mirror is infinity. So coming to the power is 0. What is the value of speed of light in free space? So we know value of speed of light is 3 into 10 power 8 meter per second. Speed of light in air is 3 into 10 power 8 meter per second. So very, very important. Make sure that you are learning this one. Okay. So next one, power of the plane mirror. Power of the plane mirror is 0. And what is the value of speed of light in free space? Speed of light in plane mirror. Speed of light in free space or air or vacuum you can take. So air or vacuum you can take. So 3 into 10 power 8 meter per second. 3 into 10 power 8 meter per second. So this is the speed of light in air or vacuum. Which type of reflection of light leads to the formation of images? Very, very important question. Question is, which type of reflection of light leads to the formation of image? Regular reflection. So which type of reflection leads to the formation of images? Regular reflection. Very, very important. So MCQ's point of view, I said regular reflection. Coming to the next one. So I already said the question. What is the difference between regular reflection of light and diffuse reflection of light? So regular reflection or diffuse reflection means regular reflection or diffuse reflection. The difference is so regular reflection, reflector light rays are parallel to each other. In regular reflection, reflector light rays are parallel to each other. But in irregular reflection, reflector light rays are not parallel to each other. So just 5 minutes, I'll drink water and we'll start. So regular reflection, if you see, regular reflection, okay. Welcome to the class now. What type of reflection of light takes place? On cinema screen? Irregular reflection. So here I will write on question. So if you know the answer, just you can let me know. I'll writing the answers on the board. So check once. On cinema screen. First point is cinema screen. First one. Coming to the second one, plane mirror. And the third one, cardboard. Can you tell? And still fourth one, still water. Surface of a lake. Can you tell me what type of reflection takes place on it? So on cinema screen, irregular reflection. irregular reflection. So on plane mirror, regular reflection, regular reflection. On cardboard, irregular reflection, irregular reflection, irregular reflection. On still water, regular reflection, regular reflection. I hope it is very clear to you all. So very, very important for 1 mark. For 1 mark question. So anyone will come in the board exam. So on cinema screen, what type of reflection takes place? So actually, the cinema screen, if you see, so it will be in a concave mirror shape. It is not a plane surface. So you can, if you observe the cinema screen, so the people can see until here at the corners also. So whenever the light rays are falling, it won't. So it is surface also not smooth. Even if you see, it is not smooth. Okay, that is the reason it is irregular reflection. Irregular reflection. Even surface, it depends on the surface. Okay, that's why. Okay, I hope it is very clear. Just check once. Check once. So cinema screen irregular, plane mirror regular, cardboard irregular, still water regular reflection. Next one, we are going to the next one. Next one, you are going to the next one. So already I said this question. So a wall reflect light and mirror also reflect light. What difference is there in the way they reflect light? I already said this question. Before only I said, right? So a wall reflect light and a mirror also reflect light. A wall reflect light and a mirror also reflect light. What difference is there in the way they reflect light? So I already said plane mirror reflects regular reflection. So surface if you take wall if you take irregular reflection, right? So are the laws of okay, under what conditions in an arrangement of two plane mirrors, incident and reflector will always be parallel to each other? Whatever may be the angle of incidence, show the same with the help of diagram. So here you can see they're asking one question. That is, so here, under what conditions in an arrangement of two plane mirrors, incident ray and reflected ray will always be parallel to each other? Whatever may be angle of incidence, show the same with the help of diagram. With the help of diagram, they are asking. So how the incident ray, reflected ray parallel to each other? So here you can see, if the arrangement, if the angles are placed, if the mirrors are placed with perpendicular degrees, okay, so if the light ray incidenting on it, so obliquely only, so this is the incident ray, this is the reflected ray again, and this will become parallel. So you can see incident ray and reflected ray, both are parallel to each other. Okay. So however arrangement I already said, they mentioned. However the arrangement. So this is the angle of incident, angle of reflection, angle of incident, angle of reflection. This is under what condition? Again question. So under what conditions in an arrangement of two plane mirrors, incident ray, reflected ray will always be parallel to each other? Whatever may be angle of incidence, show the same with the help of diagram. So this is the way. So you have to draw the diagram in this way. I hope it is very clear to you all. So what are the uses of plane mirror? Very, very, very important. Highly important. Super duper important. So it is like a diamond question to everyone. So like a plane mirror, uses of plane mirror. So question is, what are the uses of plane mirror? What are the uses of plane mirror? What are the uses of plane mirror? So you can see, what are the uses of plane mirror? Can you explain this one? So what are the uses of plane mirror? First one, They're used as a looking glass. First one is looking glass. So every day we are seeing when you are wake up in it, looking glass. Next one, construction in periscope, kaleidoscope, and used in solar cookers, solar cookers, solar cookers. You can see solar cookers. Third one, used in periscope, periscope. So periscope, kaleidoscope also. Kaleidoscope also. What are the uses of plane mirror? 2 marks question, very very important. So 2 marks question, very very important. Very very important. Very very important. 2 marks question. What are the uses of plane mirror? What are the uses of plane mirror? Used as a looking glass. Used as a looking. They are used as a looking glass. They are used in construction of a periscope, kaleidoscope. They are used in solar cookers. They are used in solar cookers. They are used in solar cookers. Write the properties of image formed by the plane mirror. Virtual erect. Virtual erect. The size of the image is equal to size of the object. Image distance is equal to object distance. Image distance is equal to object distance. Image distance is equal to object distance. Size of the object equal to size of the image. Size of the object is equal to size of the image. So object distance is equal to image distance. Object distance is equal to image distance. So it also shows lateral inversion. It also shows lateral inversion. It also shows lateral inversion. I hope it is very clear. Next one. The magnification produced by the plane mirror is +1. So magnification. Okay, so the question is magnification of the plane mirror is +1. What does it mean? So magnification produced by the plane mirror is +1. So you are considering here. So now you can see. So I'm considering here. Okay, I'm considering here. So the magnification produced by a plane mirror is +1. By a plane mirror is +1. What does it mean? What does this mean? So here, as I already said, only in the plane mirror. So it is. What does this mean? What does this mean? What does this mean? The magnification, here you see, the magnification produced by the plane mirror is +1. The magnification produced by plane mirror is +1. What does this mean? What does this mean? Hello? So, Victor? Okay, so here I already said size of the object equal to size of the image. Size of the object equal to size of the image. Size of the object equal to size of the image. So image will form always virtual erect and same size. Image always will form virtual erect and same size. So that's why image will form always virtual erect and same size. That's why it is magnification is +1. Magnification is +1. So, okay, and one more thing, okay, so I'll do it. So, one more thing, paraxial rays and marginal rays. Very, 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 very important. Very, 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 very important. Very, 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 very important. Paraxial rays and marginal rays. Paraxial rays and marginal rays. The rays which are very close to the principal axis. The rays which are very close to the principal axis, those are called paraxial rays. The rays which are very so I am considering here. So here you can see. So paraxial rays and marginal rays. If you are taking the concave mirror like this, if you are taking the concave mirror, I'm considering here. So paraxial rays and marginal rays. If you are taking like this, the rays which are very close to the principal axis, those are called. So here you can see there are many rays. Are coming from infinity. So like this. So the rays which are very close to the principal axis. So you are considering here. So they are very nearby. I'll tell. So these rays will use. So this rays will see these are very close to the principal axis. These rays are very close to the principal axis. This is the principal axis. This one is the principal axis. This one is the principal axis. The rays which are very close to the principal axis, those are called paraxial rays. The rays which are very close to the principal axis, those are called paraxial rays. The rays which are away from the principal axis, those are called marginal rays. The rays which are near to the principal axis, those are called paraxial rays. The rays which are away from the principal axis. So at the edge of the mirror you are taking, no. So those rays are marginal rays. The rays which are very close to the principal axis, the rays which are very close to the principal axis, those are called paraxial rays. The rays which are very away from the principal axis, those are called marginal rays. Okay, so this is about paraxial rays and marginal rays. So next one we are going to the spherical mirror. Come on, spherical mirror. So very important, spherical mirror. So the mirror which is in the form of curved shape, those are called paraxial rays. The rays. So here I'm considering. So normally if you take, so this is the, wow, nice. So here if you are taking this small portion, that is called curvature. The small portion is called curvature. So based on the reflection. So the mirrors are divided into two types. Based on the reflection. Yeah, of course. Even I felt same thing. Perfect circle. Okay, the rays, based on the reflection, the mirrors are divided into two types. Concave mirror, convex mirror. So I'm considering here like this. Okay, so like this I'm considering here like this. Okay, so here concave mirror is also known as converging mirror. Convex mirror is also known as diverging mirror. Convex mirror is also known as diverging mirror. Concave mirror is also called converging mirror. Convex mirror is also diverging mirror. One example I will tell. So in the morning time, so you are moving from your home to an ocean. So if in the morning time, you are going to school or college from the homes. From homes you are going to school or college. Yes or no? From school or college you are going to from home to school or college. From home to school or college. Morning. From home to school or college. Okay. So that point. If you are taking from home to school or college, you're going from different places, so people will be from different places, reaching to the one point, from different places, from home to school or college, from different places you are reaching to school or college. Okay, so here also the light rays are coming from infinity. After reflection, those light rays are meeting at one point. After reflection, low light rays are meeting at one point. So converging. Simple one, home to college. Yes, home to college. Okay. So after reflection, those light rays will meet at one point. So there, so image will form. Like so, those light rays are meeting at one point on the principal axis. So converging. That's why it is also known as. That's why it is also known as converging mirror. Concave mirror is also known as converging mirror. Concave mirror is also known as concave mirror, converging mirror. Concave mirror is also known as converging mirror. Converging mirror. Concave mirror is also known as converging mirror. Whereas convex mirror, like this I am taking. Convex mirror. Okay, so if you are taking like this, if you are extending this one, okay. So here you can observe, after reflection, light rays are moving away from the principal axis. After reflection, sir, please repeat. Okay, so here you see light rays are coming from infinity. After reflection, those light rays are meeting at one point, right? After see. So light rays are coming from infinity. After reflection, those light rays are meeting at one point, means moving close to the principal axis. After reflection, light rays are moving towards the principal axis, close to the principal axis. That's why this mirror is also known as converging mirror. This mirror is also known as converging mirror. So here in convex mirror, you see, after reflection, light rays are moving away from the principal axis. After reflection, light rays are moving away from the principal axis. So this mirror is known as diverging mirror. Convex mirror is also known as convex mirror. Convex mirror is also known as diverging mirror. Okay. Now we will discuss about ray rules. Ray rules of concave mirror. Ray rules of concave mirror. So if you are going to exam hall, you need weapons for writing exam, like a pen, geometry box, like that. Okay, here also same thing. If you want to draw the image formations, so compulsory you need ray rules. So first one is concave mirror. I am taking concave mirror. Concave mirror I am considering. First one I am taking. So here, so both I will draw concave mirror and convex mirror. Concave mirror and convex mirror. Concave mirror and convex mirror I will draw. So this side is concave mirror, and this side is convex mirror, So concave mirror. So first diagram. So this is a pole, focus, center of curvature. Pole, focus and center of curvature. After reflection, light rays will pass. So after reflection, light rays passes through the focus. First one, after reflection passes through the focus, first one. Coming to the second one. Second one, if you are taking here, so pole, focus, center of curvature, light ray passes through focus. After reflection, passes towards infinity. So light ray passing like this. Okay, so I'm considering here. So third one you can see. Third one I'm taking. Pole, focus, center of curvature. If the light ray passes through center of curvature, it retraces its original path. If the light ray passes through center of curvature, so if the light ray passing through center of curvature, okay, so it retraces its original path. Fourth one, pole, focus, center of curvature, light ray incident at the pole, it reflect. So these are the rare concave mirror. Coming to the convex mirror, first one, convex mirror. Light ray is coming parallel to the principal axis after reflection. So passes through the focus like this. Second one, so pole, focus, center of curvature. So light ray is passing through the focus after reflection, passes towards infinity. Third one, so if the light ray incident at the center of curvature, like it passes through center of curvature. Okay, so it passes through center of curvature. Okay, so like this. And coming to the fourth one, so pole, focus, center of curvature. The light ray incident at the pole, it reflect back. So these are the ray rules. Once again, light rays coming from infinity after reflection passes through the focus. So here second one, if the light ray passing through the focus after reflection move towards infinity, if it is passing through center of curvature, it retraces its original path. If the light ray incident at the pole, it reflect back. Here, if the light ray is coming from infinity, this one after coming to infinity after reflection passes through focus. The light ray passing through the focus, if you extend, passes through focus. Okay, it passes through focus. So after reflection moves towards infinity. Here, if the light ray passing through center curvature, it retraces its original path. So next one, if the light ray incident at the pole, it reflect back. So these are the concave mirror and convex mirror. Concave mirror and convex mirror image formations. Concave mirror and convex mirror. So actually one point is there. So that is about terms related to spherical mirror. So even though we did ray rules, so already those points I hope it know, but still I'll explain. Terms related to spherical mirror. So just now I represented the pole, focus, and center of curvature, right? So those will discuss. Okay. So now I'm considering the concave mirror. Actually, this is a part of the sphere. Like this. Part of the sphere. Okay. So it is the center of the imaginary sphere in which mirror is a part. First one, center of the imaginary sphere in which mirror is a part. So if you are taking this is a sphere, entirety is sphere. So in the entire sphere, so the center of the imaginary sphere in which mirror is a part. center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part is called center of curvature. It's called center of curvature. Second one, so pole. The midpoint of the mirror is called pole. 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 And coming to third one, the distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. And after reflection, so if you are taking the light rays like this, after reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays will meet one point on the principal axis. After reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays are meeting at one point on the principal axis. That is called so focus. Simply so actually principal focus. Simply we can say focus. The distance between focus to pole is called focal length. So the distance between focus to pole is called. So actually this capital F, you are taking capital F. This is a capital F if you can take. And coming to the fifth one, small f. The distance between focus to pole is called focal length. And coming to the sixth one, the line joining of center of curvature and pole. The line joining of center of curvature and pole is called principal axis. The line joining of center of curvature and pole is called principal axis. The line joining of center of curvature and pole is called line joining of center of curvature and pole is called principal axis. Line joining of center of curvature and pole is called principal axis. Line joining of center of curvature and pole is called principal axis. Coming to the seventh one, so width of the mirror is called aperture. Width of the mirror is called aperture. Once again, so C is nothing but the center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part. So pole, the midpoint of the mirror is called pole. 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 So the distance between center of curvature to pole is called radius of curvature. Distance between center of curvature to pole is called radius of curvature. Distance between center of curvature to pole is called radius of curvature. So after reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays will meet at one point on the principal axis. That is called focus. So actually principal focus. So simple word is focus. So the distance between focus to pole is called focal length. Distance between focus to pole is called focal length. And the line joining of center of curvature and pole is called principal axis. Line joining of center of curvature and pole is called principal axis. The width of the mirror is called aperture. Okay, so this is about terms related to spherical mirror. Next one, we are going to the image formations by concave mirror. Okay, so image formations by concave mirror will discuss. Okay, so now you will see, now we are considering first one. So concave mirror, image formations by concave mirror. Image formation, concave mirror. So first one I am considering. So this is a concave mirror, like this I am taking. Okay, concave mirror, pole, focus, center of curvature, pole, focus and center of curvature. So if you are taking object at infinity, so one light ray I am taking like this. So after reflection, those light rays will meet at one point on the focus. Okay, so the light rays will meet at focus. Those light rays will meet at focus. Focus. Object at infinity, image will form at focus. Nature of the image is real and inverted. Size of the image is highly diminished. Nature of the image is real and inverted. Size of the image is highly diminished. Coming to the second one. So second one I will draw here. Second one. So here once again object. So object is at infinity. Object is at infinity. Image will form at focus. Nature of the image is real and inverted. Real and inverted, real and inverted, real and inverted, real and inverted. Size of the image is highly diminished. Highly diminished. Coming to the second one. Second one if you are taking. So object is placed. This is the pole, focus, center of curvature. Object is placed beyond center of curvature. In this case, object is at infinity. Now I am placing object at beyond center of curvature. Object is placed beyond center of curvature. One light ray I am taking like this. It passes through focus, and one more light ray is passing through center of curvature. So anyway, to reflect back. So here, so the image will form here between center of curvature and focus. Between center of curvature and focus. Object is placed beyond center of curvature. Object is placed beyond center of curvature. Image will form between C and F. Image will form between C and F. Nature of the image is real and inverted. Size of the image is diminished. Compared to the object, image size is decreased. Coming to the second one, I am taking here. So now this is the pole, focus, center of curvature. Pole, focus and center of curvature. Here in this case, object is at infinity, image will form at focus. In this case, object is placed beyond center of curvature, image will form between C and F. So now I am placing object at C. One light ray I am taking like this, it passes through focus. Okay. So object, so center, object is C, image also will form at C. Object at C, image also will form at C. Nature of the image is real and inverted, and size of the image is same size. So what type of image will form here? Same size. So nature of the image is same size. Size of the image is same size. So here you can see object is placed at C, image will form at C. So nature is real and inverted, size is same size. Okay. So next one, this is the third one. Next one, coming to the fourth one. Pole, focus, center of curvature. So if you are placing object between C and F, one light ray I am taking like this, it passes through focus, and another light ray is incidentting at the pole. So those light rays will meet. So object is placed between C and F. Image will form beyond C. Nature of the image is real and inverted. Size of the image is enlarged. Compared to the object, image size is increased. So next, fifth one I am explaining. So fifth one I am drawing. So now you can see Fifth one you're drawing. So here I'm considering. So pole, focus, center of curvature. Object is placed at F. One light ray taking like this passes through focus. Another light ray incidentting at the pole. Reflect. So here you can observe. Object is placed at F. Image will form at infinity. So nature of the image is real and inverted. Size of the image is highly enlarged. The last case is very, very important. Sixth case. You can take here. So I'm taking here. So here in this case, virtual erect and enlarged image will form. Very, very important. You can check it here. So object is placed between F and P. Image will form behind the mirror. Behind the mirror. Nature of the image is virtual erect and enlarged. Because compared to the object, image size is increased. Yes or no? Check once all the diagrams. So check once. Syam, hi. Check once all the diagrams. I hope it is very clear to you all. So check once, if you have any doubts you can ask. So we'll discuss a few more points we need to discuss. Few more points. I'll explain remaining. So related to sign conventions we need to discuss. Okay, I'll explain. So meanwhile you can go through it once observe. I'll resume the class now 10:32. So 10:42 again I will explanation I will start. 10:42 explanation will start again 10:42. Okay. So I hope it is very clear. So check once, I'm removing this one. Second image formations. So explanation. Explanation at the rate of 10:42. Okay, wait until that time. So small break. I hope so. It is time for resuming the class. So let's start the resuming the class. So we'll continue the class. So this is about image formation. Image formation completed by concave mirror. Concave mirror image formation is completed. Next we'll discuss about convex image formation. We'll discuss about convex image formation. We'll see you now. Okay, so let's start the class. Let's continue the class. Let's continue the class. Okay, so now we are considering. Now we are considering. So come on, explanation. Ready. Convex mirror. Convex mirror always forms virtual erect and diminished image. Convex mirror forms always virtual erect and diminished image. Convex mirror forms virtual erect and diminished image. Come on. So here I'm considering. See. So I'm taking the convex mirror image formation. Convex mirror. Okay. Convex mirror. Right. Convex mirror forms always virtual erect and diminished image. So I'm taking first one. So here I'm taking light rays are coming from infinity. Light rays. So this is the pole. Focus. Center of curvature. Light rays are coming from infinity. After reflection. Here. So those light rays will meet at focus. Those light rays will meet at focus. Okay, so I'm considering here like this and like this. Okay. So object is at infinity, image will form at focus. Nature of the image is virtual, erect and highly diminished because point size image is formed at focus. Point size image is formed at focus. So virtual, erect and diminished image. Second one if you are taking, second one I'm considering here. So this is the pole, focus, center of curvature. Object is placed anywhere between pole and infinity. Object is placed anywhere between pole and infinity. So I am taking one letter like this. Okay, after reflection passes, another light ray inciding at the pole, it reflects back. So if you are extending those light rays, so image will form here. Thus, image will form. What type of image will form? Virtual erect. And so virtual erect and diminished. So object is between pole and infinity. So image will form between P and F. Object is placed between pole and infinity. So pole and infinity. Anywhere it can be placed. Object is placed between pole and infinity. Image will form between P and F. Nature of the image is virtual erect and diminished. Compared to the object, so image is decreased. Compared to the object, image is decreased. Yes, sir, you still there? Okay, done. So next one we are going to the sign conventions. Come on, sign conventions. So I'm taking sign conventions. So if you are taking the concave mirror here, concave mirror I'm taking. So this is the pole, focus and center curvature. Pole, focus and center curvature. All the measurement will be taken from the pole. In the direction of incident rays, all are positive. Object distance, image distance, focal length and radius of curvature, all are positive. Opposite to incident rays, object distance, image distance, focal length and radius of curvature, all are negative. Above the principal axis, height of the image and height of the object both are positive. Below the principal axis, height of the image and height of the object both are negative. So all measurement will be taken from the pole. In the direction of incident rays, In the direction of incident rays, all are positive. Opposite to incident rays, all are negative. So all distance are measured from the pole. In the direction of incident rays, all are positive. Opposite incident rays, all are negative. Above the principal axis, all are positive. Below the principal axis, all are negative. If you are taking the coordinate axis, so all measurement will be taken from the pole. So in the direction of positive x-axis, negative x-axis, positive y-axis, negative y-axis. So here all measurement will be taken from the origin. So similarly, so in the concave mirror also, all measurements will be taken from the pole. In the direction of incident rays, all are positive. Object distance, image distance, focal length and radius of curvature. So opposite incident rays, object distance, image distance. So focal length and radius of curvature all are negative. Above the principal axis, all are positive. Height of the image and height of the object. So below the principal axis, height of the image and height of the object, height of the image and height of the object, all are negative. So come on now. So the same thing will be discussed in the form of song. Cartesian sign convention, all distance measured from the pole, distance positive along the instant rays, distance negative opposite to instant rays, distance positive above the principal axis, distance negative below the principal axis. Cartesian sign convention, Cartesian sign convention, all distance measured from the pole, distance positive along the instant rays, distance negative opposite to instant rays, distance positive above the principal axis, distance negative below the principal axis. Come on, below the principal axis. Cartesian sign convention, Cartesian sign convention, all distance measured from the pole, distance positive along the instant rays, distance negative opposite to instant rays, distance positive above the principal axis, distance negative below the principal axis. Cartesian sign convention, Cartesian sign convention, all distance measured from the pole, distance positive along the instant rays, distance negative below the opposite to instant rays, distance positive above the principal axis, distance negative below the principal axis. Okay, come on. So next we are going to the next one. So I hope it is very clear to you all. All distance are measured from the pole. In the direction. All distance are measured from the pole. In the direction of incident rays, all are positive. Opposite incident rays, all are negative. Above the principal axis, all are positive. Below the principal axis, all are negative. So all measurement will be taken from the pole. I hope it is very clear to you. So next one, we are going to the next one. We are going to the next one. So now we'll see. So mirror formula 1 by f equal to 1 by v plus 1 by u. Mirror formula equal to 1 by f equal to 1 by v plus 1 by u. So magnification equal to height of the image by height of the object. Height of the image by height of the object. Now you can see. So we will see the points related to. Oh my god. So one more question is there. So one more question. Come on, one more question. So we'll discuss. So that is radius of curvature is the twice of the focal length. Radius of curvature is the twice of the focal length. So I will discuss now. I am taking the concave mirror like this. Concave mirror. So I am considering like this. So this is the concave mirror. This is the pole, focus, center of curvature. Pole, focus and center of curvature. So here you can observe. One thing. So light ray is coming from infinity. So I'm taking AB. So light ray is coming from infinity. After reflection, what happens? Light ray must passes through the focus. Yes or no? Light ray must passes through the focus. So according to this, we can observe. According to this, we can observe. So thank you everyone for supporting. So this angle of incidence and angle of reflection. So we know from loss of reflection, angle of incidence equal to angle of reflection, right? From loss of reflection, angle of incidence equal to angle of reflection. So this theta, if you take, this is also theta. So we can take alternate angles. So this is the Z rule. So if you are taking this angle and this angle are both are equal alternate angles, and this angle also equal, this angle and this angle. So this angle equal. Suppose I am taking x and y. So x equal to y and x equal to z. Then y equal to z only, right? So in that way, once again I will explain. Listen carefully. Once again I am explaining. Just focus on it carefully. So from this one, angle of incidence equal to angle of reflection. So x equal to y. Suppose x is theta and y equal to theta. If you are taking angle of incidence equal to angle of reflection, by that, so I am taking s equal to y. If you are considering, so x equal to y. So this angle equal to this angle. So if you are taking this alternative angle, so from here center angle and this angle, these two angles are equal because alternative line angle. So these two are equal. So this angle equal, and this angle. Suppose I am taking x, y, z. I am taking x equal to y. Okay. So here z I am taking z. So x equal to z. So if x equal to y, x equal to z, automatically y equal to z, right? So these two angles are equal. So once again, so angle of incidence equal to angle of reflection. So by that rule, so x equal to y, and alternative angles are equal. So this angle and this angle both are equal. X equal to z. X equal to y, x equal to z, then y equal to z means, so here angle and here angle equal. In a triangle, if you are taking this a triangle, this is the triangle. If you observe carefully, okay. So this is the triangle. Right? In a triangle, this angle equal, z angle and y angle equal. If two angles are equal, that's it. The triangle is called isosceles triangle. Then if isosceles triangle, so two sides are equal. So then I am taking, this is the some k, some L and K. So these two sides are equal. L equal to K. So that is equal to P. So this point is very close to P. If B is very close to P, so as I said, paraxial rays. Before I said we are taking paraxial rays. Paraxial rays are nothing but the rays which are very close to the principal axis. Before I said paraxial rays and marginal rays. So the rays which are close to the principal axis, those are called Paraxial rays. So here, if this B is very close to P, automatically F equal to automatically FB equal to BP. So FB equal to BP. So M also we can take. Then CF equal to FP. CF equal to FP. So we know the distance between F and P, that is nothing but focal length. And here also, this also focal length only, right? Focal length only, right? So from center to pole is called radius of curvature. From center to pole is called radius of curvature. Then by this conclusion we can take R equal to 2F. R equal to 2F. R equal to 2F. So F equal to R by 2. Very, very important proof. So once again I will explain, listen carefully. Once again I will explain, listen carefully. I am taking here. So this is the incident ray, reflected ray. Incident ray after reflection passes through the focus. Okay, so angle of incident equal to angle of reflection. So angle of incident equal to angle of reflection. Angle of incident equal to angle of reflection. By that, so I am taking x here and y. So these angles, suppose I am taking x and y. Yes, sir, x and y are equal. So x and y are equal. Now, this alternative angles, if you are taking, so z rule, so this angle and this angle are equal. X and z are equal. Then if it is x equal to y, x equal to z, then automatically y equal to z. So if two angles are equal in a triangle, then that is isosceles triangle. Isosceles triangle. So this CF and FP both are equal. These two sides are equal. So as I said, the paraxial rays. So this point is very close to P. Then automatically, so this point is very close to P. Automatically, this will become FP. FP is nothing but focal length. FP is nothing but focal length. Automatical CF. So they already said this is equal to this one. So already this one is F. This one also F. Then F plus F to F. So R equal to 2F. Radius of curvature is nothing but twice of the focal length. Twice of the focal length. Very, very important phenomena. So make sure that you are learning this one. Next one, we are going to the next one. Next one. So next one you will see. Now we'll discuss. So question and answers we'll discuss. R equal to 2F. Uses of concave mirror. So where we'll use concave mirror? Concave mirrors are used in torchlight, searchlights, church lights, vehicles, headlights to get parallel beam, saving mirrors, and the dentist. Dentist will use this concave mirror to observe the teeth of the patients. And a large concave mirrors produce sunlight. Okay, sunlight. So like a solar furnace, it will be used in solar furnace. Okay, next one. Use of convex mirror. Convex mirror used as rear view mirror. Convex mirror is used in rear view mirror. Why we are using convex mirror as a rear view mirror? Because so field view of convex mirror is more. Field view of convex mirror is more compared to the concave mirror. Field view of concave mirror is more compared to the so remaining mirror. So normally if you take this a concave mirror, I am taking the concave mirror like this. Concave mirror. I am taking the plane mirror. So plane mirror I am considering here. This is a concave mirror, plane mirror. Next one we are taking the convex mirror. Next we are taking the convex mirror. So here if the light rays are incidenting, so those light rays reflect like this. Those light rays reflect like this. Okay. So here if you are taking when the extreme reflector light rays, so this will happens like this. This will reflect like this. Okay, but whereas convex mirror, if you observe convex mirror, when the light rays incident on it, so this will reflect back. This reflect like this. So this is the field view. This much will be there. So the field view of convex mirror is more compared to the remaining mirrors. Plane mirror and concave mirror. Convex mirror. This is a convex mirror. Convex mirror field is more compared to the plane mirror and concave mirror. That's why. So if we can see the large field view. So okay. So if, that's why we are using. Rear view mirror in vehicles. That's why we are using rear view mirrors in vehicles. So we to see the flow of the okay topic behind us, so we can cover the traffic, whatever it is coming behind of us. Okay, and use sharp security mirrors used in diffusing the light from the bulbs in floodlights. Convex mirror used as a reflecting telescope. And next one, define the terms they mention: concave pole, central curvature, radius of curvature, principal axis, aperture, principal focus, like that. So name the mirror. So here a question is, name the mirror which can give an erect and enlarged image of the object. So name the mirror which can give the enlarged, virtual erect and enlarged image of an object. Name the mirror. So here the question is, name the mirror which can give erect and enlarged image of the object. Concave mirror. Name the mirror an erect and a diminished image. Erect and diminished image. Convex mirror. So an erect and same size of the image. Plane mirror. Okay. So distinction between concave mirror and convex mirror. Reflecting surface of concave mirror is bulged inwards. So in convex mirror, reflecting surface is bulged outwards. So in concave mirror forms virtual erect and diminished image and real inverted image also. And convex mirror forms virtual and diminished images. The concave mirror has real focus. Concave mirror has real focus, whereas convex mirror has virtual focus. Concave mirror has real focus. Convex mirror has virtual focus. So concave mirror is also known as converging mirror. Concave mirror is also known as converging mirror, whereas convex mirror is also known as diverging mirror. Convex mirror is also known as diverging mirror, right? Okay. So next one we are going to the focal length of concave mirror is negative. The focal length of convex mirror is positive. Focal length of the convex mirror is positive. Next one. So there are many questions are there. If you discuss, so it will take time. Now I will explain about. So Shivani, what is your doubt? Can you tell me? So what is given? Object distance is equal to 30 kilometer per hour, right? So V equal to 0 meter per second and S equal to 10 meter. Correct? This their data is correct or not? Tell me. Yes, sir. Okay. So here U equal to 30 kilometer per hour. Convert into meter per second. 30 into 5 by 18. 5 by 18. 5 by 18. Now, so let it be. So keep it like this itself. So if you want to multiply also, just keep it like that. Now formula is V square minus U square equal to 2AS. So V square anyway 0. U square is 30 into 5 by 18 into 30 into 5 by 18 equal to 2 into A into 10. Correct? Okay, so if you multiply, how much you are getting this one? 30 by 5 by 18 into 30 by 5 by 18. Can you solve it? How much you got? Can you solve it once? Try. I hope 69.1. Huh? Acceleration. No. So 5 by 18 we are multiplying 30 into kilometer per hour, meter per second. Okay. So how much you got? 25 by 3. Huh? 25 by 3 minus 25 by 3 whole square. Whole square equal to 2 into 10. So into A. So A equal to minus 25 by. So that is about 625 by 9. 625 by 9, right? Okay. So now you are saying A equal to So 625 by 9. Again here I will get 20. This will goes down. So this is the A. So normally if you are taking A equal to V minus U by T. So T equal to 0 minus U by A. So U how much? This only, right? 30 into 5 by 18. 30 into 5 by 18 minus. Here also by minus 625 by 9 into 20. Correct? Actually, if you are without multiplying this term, one term will get cancelled, right? One term complete will get cancelled. So if you do it, if you are without solving also, see here one thing. Anyway, if you are not solving also, so let it be. Okay, so until here I said, so let here. So we'll get 2 into A into 10. Okay, so same thing. I'm considering same thing. Let it be now. A equal to V minus U by T. Okay, T equal to, so 0 minus, so 30 into 5 by 18. So one term by, so this value minus 30 into 5 by 18 into 30 into 5 by 18. Okay, so into 20 will get, so 1 by 20. So this one, if it is goes that, so 1 by 20 you can take. Now, so this entire terms will get cancelled. T equal to, anyway plus plus cancel. If it is goes into 18 into 20 by 13 into 5. So 5 4 ja. 5 4 ja. Now still T 18 into 4 by 30. Can you do it? How much you'll get? So like this also you can solve. We have to find out time, right? We have to find out time. Finally, we have to find out time. That is a question. Oh my God! Exactly got it. One person said. One of the person, I hope, Kushal Singh. I hope he said correct answer. Only we got. This is the easy method. See, we don't even see. We didn't even solve. We didn't even multiply anything. Just we cancelled terms, whatever it is left over. So simple way to solve. See, we no need to break the heads. So how to solve in easy way? That we have to approach. The approaching method must be there. Okay, we have to approach in that way. Definitely will get any problem. Easy only. You got exactly 2.4. So check it once. You'll get exactly 2.4. Okay, na Shivani? Are you happy now? Sir, another question, please. Okay, we'll see. Actually, no, in middle of the topics, see, we discussed this one. Actually, the flow is different way. The flow is different way. Okay, let it be go for another go. Okay, Savani, if you have any questions, we'll see later. Try to solve it. See, that method is different, ma'am. Method is different. If you are not able, see, calculation only we do mistake. Calculation only will make it more complex. Yes, it was getting 2.4. That is only correct. That is only correct. 2.4 is correct. Okay, done. Come to the next one. So we are going to discuss about refraction phenomena. Refraction is nothing but, so when the light ray is passing from one medium to another medium, this is the rarer medium and denser medium. If the light ray is passing from one medium to another medium, so the light ray bends at the interference of the two media. The light ray will bend so it is bending at the interference of the two media. The angle between incident ray and normal line is called angle of incident. Angle between refracted ray and normal line is called angle of refraction. Angle between incident ray and normal line is called angle of incident. Angle between refracted ray and normal line is called angle of refraction. So in this case, angle of incident is greater than the angle of refraction. Angle of incident is greater than the angle of refraction, because when the light ray is moving from one medium to another medium, the bending of the light takes place at this point. So the bending of the light ray takes place because speed is decreasing. Speed is decreasing. That's why it is moving towards the normal line. So moving towards the normal line. Okay, moving towards the normal line. So next one, if the light ray is moving from denser to rarer, if the light ray is moving from denser to rarer, so this is the angle of incidence, and this one is the angle of refraction. Angle of incident and angle of refraction. So in this case, angle of refraction is greater than the angle of incident, because so in this case, angle of refraction is greater than the angle of incident, because when the light ray is moving from denser to rarer, the speed of the light increases. Speed of light is increases. That's why. So the light ray is moving away from the principal axis. Light ray is moving away from the principal axis. Next one, we are going to the next one. Okay. So very important concept. Very important concept. When the light ray is passing like this. When the light ray is passing, so I am taking the light ray passing from denser to rarer. So normally refraction phenomenon is, so it moves away from the normal line. So light ray, if it is passing from denser to rarer, if the light ray is passing from denser to rarer, it moves away from the normal line. So angle of refraction and angle of incidence. Angle of incident here, angle of refraction. If the light ray is passing from denser to rarer, it moves away from the normal line. It moves away from the normal line. So same thing if you are taking, if the light ray is coming from denser to rarer, at the point of incidence, it passes, it gazes along the surface. So this is the angle of incidence. So here you can observe the angle at which, so here you can observe the angle at which, at a certain angle, the refracted ray passes along the surface. The refracted ray gazes along the surface. The refracted ray passes along the surface. The refracted ray gazes along the surface. So here you can see, at certain angle, the refracted ray passes along the surface or gazes along the surface in the rarer medium, or it makes 90 degrees. The refracted ray makes 90 degrees with the normal line. So that is called critical angle. So that is called critical angle. Okay. Next one, if you are considering one more light ray. So if you are considering one more light ray, okay. So one more light ray I am taking here. So at certain angle, if the light ray is so makes more than critical angle, here 90 degrees. So here so theta I am taking. If it makes more than critical angle of incident is more than critical angle. So at certain angle in the refracted ray makes more than critical angle, more than 90 degrees, then it will reflect back into the same medium. So this reflection is called total internal reflection. So the light ray is passing from denser to rarer. So in the refracted ray, refracted ray makes more than 90 degrees. Then the light ray will reflect back into the same medium. So this type of reflection is called the total internal reflection. So next one, we are going to the lenses. So lens we are going to discuss. So before that, refractive index I am considering. So this is the glass slab I am taking. I am considering. Okay, glass slab. So this is the incident ray. So I am taking the normal line here. Normal line height. This is the refracted ray. Incident ray, refracted ray, normal line. So normal line, and this is the emergent ray. Here you can consider this is the incident ray, refracted ray, emergent ray. Incident ray, refracted ray, emergent ray. Okay. Incident ray, refracted ray, and emergent ray we are taking. So now, if you are extending this incident ray, that will become parallel to the emergent ray. So whatever we are extending, that extended incident ray become parallel to the emergent ray. Okay, so the distance between The distance between emergent ray and extended incident ray is called lateral shift. Lateral shift. Lateral shift. Lateral shift. Lateral shift. The distance between emergent ray and extended incident ray. The distance between emergent ray and extended incident ray. The distance between emergent ray and extended incident ray is called lateral shift. Okay, so incident ray, incident ray, incident ray, incident ray, incident ray, refracted ray, normal line. So this is the emergent ray. Emergent ray, okay, emergent ray. So the light ray which is coming out, so that is called emergent ray. This is the extended incident ray. So this is the refracted ray. The angle between incident ray and normal line is called angle of incident. Angle between refracted and normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. Angle of emergence. Here you can observe. Here you can observe one thing. Here you can observe one thing. Here you can observe one thing. So the distance between the vertical displacement, the vertical distance between emergent ray and extended incident ray is called lateral shift. Lateral shift. So if the same thing, if you are taking a beaker I'm considering. So beaker I'm considering here. Beaker. So if you place the coin at the bottom of the beaker, if you place the coin, so I'm taking the beaker. So I'm standing here. So I place the coin. So at the bottom of the beaker. So I can't able to see at this position. So after pouring water, the coin position appears to be here. The coin position I rises up. So this is called. So here is the apparent position. This is apparent position. And this one is called a real position of the object. Real position. Okay. So real position of the coin, and this one is the apparent position of the coin. The distance between real position to apparent position is called vertical shift. The distance between real position to apparent position is called vertical shift. So after pouring water, the coin position appears to be raised. Okay, the coin position rises up. So the distance between apparent position, so this is actual position and this is apparent position. Actual position, apparent position. The distance between actual position to apparent position is called vertical shift. The distance between emergent ray to and extended incident ray is called lateral shift. So very, very important these points. And here related to this one, there are 3 questions they will ask. And a lemon is placed inside of the gas tumbler. Lemon is placed inside of the beaker. It appears bigger. And one more thing, if you are placing the pencil, so pencil if you place also at this position at the interference of the water and air, so at this surface, the position is appears here. The position is appears. So at this position, the pencil appears to be bent. So the pencil appears to be bent. Okay. So at this position, the pencil appears to be bent. Okay. So at the point of interference of the water and air. So water and air. So at the position of the interference of the water and air. So we can see, so the object appears to be bent. Okay. Object, that is nothing but pencil appears to be bent. So that is nothing but what is that one? So that is a refraction. Because of the refraction only it is happening. Understood? So I hope it is very clear. So 3 questions are related to gas tumbler. Related to lemon placed inside of the gas tumbler. Okay, so that one. And one more point. Pencil placed inside of the water. Okay, it appears to be bent at the interference of the 2 media. And Third one, coin. Coin is placed at the bottom. So the distance between actual position and apparent position of the coin is called the distance between actual position and apparent position of the coin is called vertical shift. Vertical shift. I hope it is very clear. Lateral displacement depends on incident angle, angle of incident, refractive index, and wavelength of the light. Wavelength of the light. Once again, lateral displacement depends on angle of incidence, refractive index of the glass slab, and wavelength. Coming to the next one. So lens, convex lens, ray rules, convex lens. And one more thing, refractive index is there. Related to surface. Now we are considering refractive index. So refractive index is nothing but speed of light in vacuum by speed of light in medium. If you are taking light is incidenting on it, so if you are taking the normal line, so light ray passes. So Snell's like normally last refraction, if you are taking incident ray, refracted ray, normal line. Incident ray, refracted ray, normal line lies on the same plane. Incident ray, refracted ray, normal line lies on the same plane. Second point is angle of incident is equal to angle of refraction. Angle of incident is equal to angle of refraction. Angle of incident is equal to angle of refraction. So incident ray, refracted ray, normal line lies on the same plane. Angle of incident is equal to angle of refraction. So now we are going to the next one. Okay. So here if you are taking, so Snell's law is this only. So sorry. This is not angle of incident, angle of refraction. That is reflection. So sine of angle of incidence. Sine of angle of incident to sine of angle of refraction. Sorry for that. Sine of angle of incident is equal to sine of angle of refraction equal to constant. That is only refractive index. So normally you are considering here. So incident ray, refracted ray, normal line lies on the same plane. Incident ray, refracted ray, normal line lies on the same plane. So sine of angle of incident to sine of angle of refraction equal to constant. Sine of angle of incident to sine of angle of refraction equal to constant. That is nothing but refractive index. So n equal to c by v. So the ratio of speed of light in vacuum by speed of light in medium. The ratio of speed of light in vacuum by speed of light in medium is equal to constant. That is nothing but refractive index. That is nothing but absolute refractive index. So relative refractive index 2, 1 you are taking. So refractive index are 2, 1. Like that also we can take. So V 1 by V2. So normally how we can write N2 by N1 equal to V1 by V2. So why we are writing like this? So here N is inversely proportional to velocity. N is inversely proportional to velocity. That's why here you can take N21 or N21. So N21 like this format we can write N21. So N is inversely proportional to velocity anyway. N is inversely proportional to velocity. That's why N2 by N1 equal to V1 by V2. N2 by N1 equal to V1 by V2. So this is about relative refractive index. Satrajit Gupta, hi. So relative refractive index. I hope it is very clear to you all. So relative refractive index and absolute refractive index. So absolute refractive index is nothing but speed of light in vacuum by speed of light in medium. Speed of light in vacuum by speed of light in medium. Speed of light in vacuum by speed of light in medium. N equal to C by V. So here relative refractive index. Is nothing but so N2 by N1, that is nothing but V1 by V2. N2 by N1 is nothing but V1 by V2. Okay. So next one we are going to the next one. So we can see next one. So actually related to this one, problems we have to do it. So even mirror formula, magnification also we need to do problems, but still we have to do it. So formulas we didn't discuss that. So we'll discuss all those formulas and problems. Okay. So Until that one we can wait. So you can wait. So we will discuss. First we are discussing the concept. So we'll go with the concept. Now we are going to the next one. Convex lens, convex lens, convex lens, convex lens, and going to the concave lens here, concave lens. So I'm going to the concave lens. Okay, concave lens, concave lens, concave lens, concave, convex lens, and concave lens, concave lens. So convex lens is nothing but if you are taking first one. So lens is I am taking the lens. So optic center F1, so 2F1, F2, 2F2. So one light ray I am taking like this, it passes through the focus. After refraction, it passes through the focus. Second one, if the light ray is passing through the focus, second one, if the light ray, so I am taking the optic center, F1, 2F1, so F2, 2F2. If the light ray is passing through the focus, after refraction, passes towards infinity. Third one, so if light ray is passing through optic center, so optic center, F1, 2F1, F2, 2F2. So if the light ray is passing through the optic center, if the light ray is passing through the optic center, no deviation, so it passes like that only. And coming to the concave lens, first one concave lens. So similar terms only I'm taking here. So optic center, F1, 2F1, F2, 2F2. So one light I'm taking like this. After refraction, it passes like this. So if you are extending, it passes through focus. So second one. So I am taking the optic center here. F1, 2F1, F2, 2F2. Light ray is coming through the passing through the focus. If you are passing through the focus, after refraction, it passes parallel to the principal axis. Third one, optic center, F1, 2F1, F2, 2F2. If the light ray is passing through optic center, no deviation takes place. So these are the ray rules. Once again, see the ray rules. Okay, you can see the ray rules. So now you observe rather high. So here you can see. So these are the convex lens. This is a convex lens. Whatever I made, this is a convex lens. Okay. So you can see this is a convex lens. Very important. Here convex lens. I only made this convex lens. You can see. So I crafted it. I hope it is very clear. So I hope it is easy to see. Okay. And here you can see. This concave lens. Concave. One is convex lens. Another one is this concave lens. Right? Yes or no? Now we are going to the next one. So here you can see concave lens and convex lens. I'll show you once again. This is a convex lens and concave lens. One is concave, another one is convex. Good, huh? So much hard work we did. Okay, done. So now we are going to the next one. Hi, Narsi. How are you? Welcome to the class. So now I am going to the next one. I'm going to the next one. You are seeing here. If the object is no, we are going to the next one. Image formations. Image formations we'll discuss. Image formations. Object is passing through the focus. First one. So Tanisha, hi Tanisha. So this is a convex lens. Convex lens. So I'm taking the convex lens like this. So optic center f1, 2f1, f2, 2f2. Object is at infinity. Sir, you are doing great work. Thank you so much. So object is at infinity, image is forming at f2. So one light I am taking like this. After refraction passes through the focus like this. So real and inverted, image is real and inverted, nature is real and inverted, and a highly diminished point size image is forming. So I will draw in normal only because it depends on space also. Object is at infinity, image will form at f2. Nature of the image is real and inverted. Size of the image is highly diminished. So object is at infinity. Object is at infinity. Sir, scene. What happened? Okay, object is. uh, So it is power, it depends on the power. The reciprocal of focal length, when power is more, it will refract. Okay, so I'm considering. So it passes. So first one, coming to the second one. So I'm taking the, so here optic center f1, 2f1. So here is f2, 2f2. So actually, if you are taking the convex like this, if you keep on deciding like this, okay, so it acts as a prism. So it is a prism manner. When light rays or falls on it, moves towards the base. That is the reason. No, it won't passes because here at the certain point, if you are, so that only I am saying. If you are taking like this at certain now, so it act as a prism. It act like a prism. It act as a prism. If the light ray passing through the prism, so what happens? So it is like a, so if you are taking like this, it will passes like this. Okay, so it is minor width only. So we can't able to identify. So as it is passes like that, so it appears like that. Okay, that is the reason. So if the light ray passing through the optic center, no deviation takes place. Okay, so first one, second one, if the object is placed at 2f1, so one light ray I am taking like this. So after that passes through the focus. Another light ray is incident at the optic center. So those light rays will meet here. Okay. So if it is passing like this, so if it is passing like that, okay, here I'm considering object is at 2f1, beyond 2f1, image will form between f2 and 2f2, f2 and 2f2, f2 and 2f2. So second one, third one is, so if you are taking the object, optic center, f1, 2f1, f2, 2f2. Okay, so if the object is placed at 2f1, so white ray, if the light ray passing through the, it is 2f2. So this is about a costume. So it is a teaching aid, one of my teaching aid. Not, so it is passing through the focus like this. So another light ray passing through the optic center. Those light rays will meet here. Okay. So object is at 2f1, image will form at 2f2, nature of the image is real and inverted, and size of the image is same size. So if the object is placed at 2f1, image also will form at 2f2 only. What's happening here? Isha cooking class. So okay, relax guys. So come to the point. Okay, here I'm considering object is at 2f1, image will form at 2f2, nature of the image is real and inverted, size of the image is same size, so say same size. And coming to the fourth one, I'm taking here fourth one. So object is placing optic center here, f1, 2f1, f2, 2f2. So object is placed between f1 and 2f1. Here object is placed between f1 and 2f1. Object is placed between f1 and 2f1. So image will form beyond 2f2. So one light ray I am taking like this. It passes through the focus. And another light ray I am taking here. Another light ray I am considering here. Okay, another light ray. So if it is passing through the focus, here I can consider f2 and 2f2, f2 and 2f2. So it is passing through optic center. Those will meet between beyond. Correct. Here in this case beyond and between. So as it is, you can see object is beyond 2f1, image will form between f2 and 2f2. Here object is placed between 2f1 and f1, image will form beyond 2f2. So same. So same. So object is placed beyond 2f1, image will form. Object is placed between beyond 2f1, image will form between f2 and 2f2. Object is placed between 2f1 and f1, image will form beyond 2f2. So like this, as it is reverse of this one. First one and the second one, as it is of reverse of this one. So I'm considering now. So here you can see optic center f1, 2f1, f2, 2f2. So object is placed at f1. Okay, so here I'm placing the object. One light ray I'm taking like this. It passes through the focus. So another light ray is another light ray passes through the optic center like this. So those light rays will not meet. So we assume light rays will meet at infinity. So object is at f1, image will form at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. So highly enlarged we are taking. Highly enlarged. Okay. So 6-1 I am taking. 6-1 I am taking. Here I am taking the convex lens. So this is the optic center. f1, 2f1, f2, 2f2, and 2f2. So object is placed between f1 and above. So one light I am taking here. So after refraction passes through the focus. Another light ray passing through optic center. So if you are extending those light rays will meet here. So behind the same side of the object. So I'm taking here. Now Object is between F1 and O. Object is placed 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 between F1 and O. Okay. Object is placed between F1 and O. Image will form same side of the object. So nature of the image is virtual, erect and so object is placed between F1 and O. So image will form same side of the object. So nature of the image is virtual, erect and enlarge. So image is image nature is virtual, erect and enlarge. Okay. So object is placed between F1 and O. Image will form so same side of the object. Nature of the image is virtual, erect and enlarge. Very, very important. So definitely it will come for 3 marks in the exam. Some is saying okay, so BC. Okay, so this type of image will form. Very, very important. Make sure that you are practicing all these points. So you are practicing all these points. Okay. So next one we'll go for concave lens. Now till now we discussed about convex lens. Now we will go for concave lens. Okay. So be ready for concave lens. Now we are going to the next one. So concave lens, only 2 cases are there. Okay, Narsi, relax. So I am taking the concave lens. I am taking. So here I am considering like this. Okay. So object is here. F1 and 2F1, F2 and 2F2, F2 and 2F2. So object is placed at infinity. So one light I am taking. So here another light I am taking like this. After refraction passes like this. So if you are extending those light rays, those will passes through like here. Object is infinity. Image will form at F1. Nature of the image is virtual, erect and highly diminished. Because point size image will form. Coming to the second case, I'm taking the second case. Okay, object is placed. So here is optic center F1, 2F1, F2, 2F2. Okay, F2 and 2F2. So object is placed anywhere between infinity and optic center. Only 2 cases are there. Tirumala Srinu, hi. So object is placed anywhere between infinity and optic center. So one light I am taking like this. After that it refract. Another light is passing through the optic center. If you are extending these light rays, if you are extending these light rays here, so these light rays will passes through the focus like this. If you are extending this, so the image will form between F1 and O. So object is at between optic center and infinity. Image will form between F1 and O. Nature of the image is virtual, erect and diminished. Nature of the image is virtual, erect and image. Nature of the image is virtual, erect and image. Nature of the image is virtual, erect and image. Nature of the image is nature of the image is virtual, erect and so diminished. Okay, so that's enough. So this is about object is placed at infinity, image will form at F1. So nature of the image virtual erect and highly diminished. Here also object is placed between optic center and infinity. Image will form between F and O. Nature of the image is virtual erect and nature of the image is virtual erect and virtual erect and virtual erect and diminished. I hope it is very clear. Coming to the next one. Coming to the next one. Okay, so I hope it is almost completed. Almost everything completed. Whatever we discussed from right from reflection to until refraction, and lenses also we completed. Lens formula 1 by f equal to lens formula 1 by f equal to 1 by v minus 1 by u, and magnification equal to height of the image by height of the object, that is nothing but v by u. V by u. Power of lens is positive for convex lens. Positive for convex lens, very very important. So power of lens is convex, positive for convex lens. Power of lens is negative for concave lens. Power of lens is negative for concave lens. So power is nothing but reciprocal of focal length. Power is nothing but reciprocal of focal length. The degree of converging or diverging of lens achieved. The degree of converging or diverging of lens achieved. The degree of converging or diverging of lens achieved. The degree of converging or diverging of lens achieved is known as the degree of converging or diverging of lens achieved is known as power of lens. Now, simply we can say reciprocal of focal length. Simple way, so easy way we can discuss. Power of lens is nothing but reciprocal of focal length. Power of lens is nothing but reciprocal of focal length. Power of lens is nothing but reciprocal of focal length. Power of lens is nothing but reciprocal of focal length. I hope it is very clear to you all. It is very clear to you all. So this is about power of lens, positive for convex lens, and power of lens is negative for concave lens. Negative for concave lens. Now I will discuss few problems related to refractive index or questions. We'll discuss now. We can see. And one more thing related to refractive index. One question I will see. One question, that is, so n1 2 and n21. What is the answer for it? n1 by n2 equal into n2 by n1. So this will get cancelled. This will get cancelled. So answer is 1. Answer is 1. Very very important point. So one more question they will ask for. They will ask in the exam. So they will ask in the exam. So n1 to n21, that is 1 get cancelled, n get cancelled, then we'll get 1 is the answer. 1 is the answer. So coming to the problems, few problems we'll discuss. Few problems we'll discuss related to refraction. Okay, so we'll see. Okay. Oh, related to refractive index. Lateral shift depends on thickness of the glass slab, angle of incident, refractive index, and wavelength. So that already we discussed. Next one. So we'll do problems. I'll write one problem. So try to do it. Almost we discussed so many points. So I hope it will be completed now. Light enters. Question number. Light enters from air into glass. Having air into glass. Light enter from air into glass having refractive index. Refractive index is 1 point. Refractive index 1.50. So what is the speed of light? What is speed of light? Speed of light in glass. So the speed of light in The speed of light in vacuum is, the speed of light in vacuum is 3 into 10 power 8 meter per second. So this is the question. Now you can observe how to solve this problem. How to solve this problem? Can you say, anybody, can you say this problem? You can observe here. So light enters air into glass having refractive index. So refractive index is given n equal to 1.5. What is the speed of light in vacuum is C equal to 3 into 10 power 8 meter per second. Okay, so we know n equal to C by V. Yeah, I completed dinner. So what about you? So 1.5 equal to, so C is nothing but 3 into 10 power 8 by V. So V equal to 3 into 10 power 8 by 1.5. So we'll get 2 into 10 power 8. 2 into 10 power 8 meter per second. 10 power 8 meter per second. So V equal to 2 into 10 power 8 meter per second. So this is the answer. So like this we have to do it. So one more problem I'll give. So try to do it. One more problem. So that is very important problem I'll give. So what is meant by? So I hope it is very clear. Next question. What is meant by, question is, what is meant by refractive index. So if the speed of light in a vacuum, speed of light in a medium is 2 by 3 of the speed of light in vacuum. Speed of light in vacuum. Find the refractive index. Find the refractive index of that medium. So can anybody solve this question? So here you can see, you can observe the ratio of speed of light in vacuum to speed of light in medium is called absolute refractive index. Speed of light in medium given. Speed of light in medium is given like that. Okay, so here speed of light in medium is how much? So speed of light in medium is 2 by 3 of speed of light in vacuum. So indirectly they given, so solution V equal to 2 by 3 of C, the refractive index of that particular medium. So normally refractive index, if you are taking n equal to C by V, speed of light in refractive index equal to speed of light in vacuum by speed of light in medium. C equal n equal to C by V. So n equal to, so C by 2 by 3 into C. So this will get cancelled. N equal to 3 by 2. That is nothing but 1.5. Yes or no? So clear? So like that we have to solve. Like this we have to solve. Once again check once. How to solve this one. So easy, simple, First you have to take. First you have to take. First you have to consider here. So what is meant by refractive index? The refractive index of medium is 2 by 3 of speed of light in vacuum. Find the refractive index of particular refractive index of that medium. Refractive index of that medium. So first we have to take. First we have to consider. So V equal to 2 by 3 of C. N equal to C by V. So C by 2 by 3 of C. C get cancelled. N equal to 3 by 2. So N equal to so it is reverse of it, 3 by 2. That is nothing but 1.5. That is nothing but 1.5. So that is nothing but 1.5. I hope it is very clear to you all. I hope it is very clear to you all. So this is about refractive index and so maximum we discussed all the points. So maximum we discussed all the points. So speed of light in vacuum by speed of light in medium. Okay. Next one related to problems, related to mirrors, reflection and refraction, related to reflection and diffraction. Next one spherical mirrors, plane mirrors, reflection, regular reflection, irregular reflection. And next one images types, real image, virtual image, real image and virtual image. After that we can go for nature of the image formed by the plane mirror. Okay, nature of the image formed by the plane mirror we discuss. Next one spherical mirrors, concave mirror, convex mirror, spherical mirror, concave mirror and convex mirror. Next one after this one, so we are going to the terms related to spherical mirror, terms related to spherical mirror, terms related to spherical mirror, array rules of concave mirror and convex mirror, image formation of concave mirror and convex mirror we discussed. Next one image formation also completed. Sign conventions also will completed. Sign conventions also completed. After that mirror formula, magnification. Next one refraction we discussed, related to refractive index, lenses, ray rules and image formations, and after that lens formula, magnification. So this all we completed in this class. Okay, so problems, few problems we did, so still few problems we need to discuss. So I hope it is very clear to you all. So if you like this video, do like, share and subscribe to Student the Brand. So if you like this content, you can subscribe. You can subscribe. You can if you like this channel, you can subscribe. And so spread one word regarding the Student the Brand. Inform to your friends. Ask them to join to the class every day at 9 p.m. We'll be having live class. So this is Shiva sir from Student the Brand. So thank you so much for joining and attending and asking question and interacting with me. Thank you so much. So signing off.